A simple security update, the kind that usually causes barely a ripple of recognition, instead triggered a worldwide tsunami.
On 19th of July 2024, the world came to a standstill.
Delta Airlines has canceled more than 600 flights that were due to take off on Monday.
A massive IT outage, one of the worst in history, crippled businesses, grounded flights, and disrupted critical services worldwide.
Global computer systems in healthcare, banking, and airlines are slowly coming back online after a digital outage disrupted networks in many countries.
The cause? A bugged update from CrowdStrike. A cybersecurity company was pushed to millions of computers running its Falcon Windows security software. In an instant, over 8 million systems crashed and could not be restarted, paralyzing airports, banks, hospitals, and countless other organizations. In the aftermath of events like this, the big question on everyone's mind then and now is, could this disaster have been prevented?
Global chaos has sparked concern over the vulnerability of the world's interconnected technologies and the extent to which a single software glitch could have such widespread impact.
And many of us are having questions about how this outage happened.
Were there better ways to deploy that update? Could they have slowed or at least contained the spread before it escalated to a full-blown catastrophe? The answer lies in software deployment strategies. Today, we're breaking down the different software deployment strategies, what they are, how they work, their strengths and weaknesses, and which ones can help prevent disasters like this. Let's dive into it. Back in the day, engineers didn't have to worry about software deployment strategies. This is because software was initially shipped bundled together with the hardware computers. If an update was needed, a system architect or consultant would have to travel to the physical location of the computer to perform the update. But as technology advanced and storage devices became more widespread and accessible, the process became much simpler. There was no need for an expert to show up on site. Instead, users could just purchase the updated version of the software and install it themselves. Cartridges and compact cassettes were some of the first storage devices used to distribute software updates. They were popular in the 80s and 90s. Soon after, floppy disks became the standard. These little disks were the go-to method for software updates, but their limited storage capacity still meant deployment wasn't as fast or efficient. Then came optical media like CDs and DVDs in the late 90s and early 2000s. These shiny disks improved the software deployment process by allowing for larger software packages and more reliable storage. Flash drives also came into the picture and were much more reliable, but still required the end user to facilitate and initiate the updates. Then came the internet. The internet revolutionized software deployment in its entirety. Its spread made cloud computing and software as a service possible, allowing software to be deployed to a vast number of users in minutes. Today, software deployments can be initiated and managed entirely by the software providers with little to no involvement from the end user. This modern approach to deployment means that in most cases, users don't have to lift a finger. Updates happen automatically in the background, ensuring that they always have the latest versions without any effort on their part. This new deployment paradigm led to the birth of continuous delivery, the CD in CI/CD, paving the way for faster, more automated, and more reliable deployments. Let's examine some of those deployment strategies and see which one could have prevented the CrowdStrike incident of 2024. Now, software deployment could mean introducing new software to users for the first time or pushing out new releases or updates to existing users. Let's say you've developed and deployed an e-commerce platform that allows users to browse products, make purchases, track orders, and much more. This cloud-based online store, like Amazon for example, is currently serving millions of users across various regions. A new release of this cloud service, say version 1.1, is ready to be deployed. What options do you have for releasing new versions to users? The most straightforward deployment method is called basic deployment. This simply updates every part of the system to introduce the new version. The new version overrides the old version with the assumption that everything will work fine. While this approach is the easiest, fastest, and most cost-effective, it comes with a lot of trade-off. Most notably, it makes rolling back to the previous version much difficult if something goes wrong. This is because there is no provision to keep the old version running on standby in case something goes wrong. This makes it the most vulnerable and carries the highest risk. It's suitable for test environments when still developing and testing, but not for production environments. You do not want to be doing this in a production environment. So what's the next option? You can perform what is known as a rolling deployment. Rolling deployment is a deployment strategy that limits the risk compared to basic deployment. It does this by chunking the update into different application sectors and updating one at a time. For example, version 1.1 of our cloud service could contain updates to the shopping cart module, the delivery and order tracking service, and the payment service. It would not contain updates to the authentication module, the inventory module, live chat, and other parts of the system. The shopping module can be updated first. We then monitor and test it. If everything works fine, we proceed to update the delivery and the order tracking module. We then test and monitor and proceed to the last module of the update, the payment service, and do the same thing. This approach offers flexibility in scaling up the new version before scaling down the old versions of the modules. This means we can have the new versions coexist with the old versions simultaneously for a short period of time until the full update is eventually completed. This approach helps ensure minimal downtime and reduces the risk during the deployment process. But it also means slower deployment because it requires a gradual approach and new versions must be backward compatible with the older versions. At this point, you might be thinking, why can't we just have two versions of the whole application running at the same time? We actually can. This is called blue-green deployment. Blue-green deployment is a deployment strategy where there are two versions of the application running simultaneously. The current version is the blue and the new version is the green. The blue version continues to run while the green version undergoes testing by the software testing team or a select group of users. Once the new deployment is ready, traffic is routed to it, and the old version is either kept on standby for future rollbacks or it's taken down. The new deployment then becomes the new blue. This strategy eliminates downtime because traffic can be instantly rerouted to the old version if things go south with the new version. The isolation also prevents bugs from affecting either version. While this strategy is less risky than rolling deployment, it has its limitations. It requires the maintenance of two identical environments, which can be expensive. It's also not ideal for incremental changes. The whole version has to be swapped all at once. Now, how can we take advantage of the high availability that blue-green deployments offer while minimizing its limitations? Well, we can use Canary deployment. Canary deployment is a deployment strategy that releases the update gradually. It does this by first exposing the new update to a small subset of users, the Canary group, and then expanding the user base if the update is successful. Companies like Microsoft, Meta, Netflix, and more sought ways to reduce the risk of publishing updates to a larger base, hence this strategy. This is why some users may experience issues related to a software update while others are perfectly fine. The software team can see how this new version fares in production and address any issues before increasing the user scope until everyone eventually gets the update. This approach eliminates downtime and enables fast rollbacks. It also carries the least risk of any deployment strategy. Now, while it prevents widespread failure because only a small set of users initially get the update, it has its limitations. It can be hard to come up with the criteria for selecting that initial small group, the Canary group. It has to be as diverse as possible to ensure it accurately reflects the broader user base and catches any potential issues early. It's also slow. Each increment in the user scope requires proper monitoring, which takes time. Now, what other strategies can we adopt? Well, we can try A/B testing. A/B testing is another strategy similar to Canary deployment used to make informed decisions about deployments. It does this by routing a small subset of users to the new version, monitoring and gathering statistics, and analyzing them to determine whether to proceed with the deployment. It's often seen as a testing approach rather than an actual deployment strategy. The beauty of this strategy is that it allows for variants of the new update to be tested by a small subset of users. Results from this test can determine which version performed better in terms of user engagement and other metrics. However, this also inherits some limitations of the Canary deployment, like the selection criteria to determine which users to use to test. Another deployment strategy that involves comparing between different versions is shadow deployment. This strategy works by releasing the new version in parallel with the current version without impacting user experience. It does this by monitoring or forking the traffic from the current version to the new version. Users would still interact with the old version, but the new version would process the same request in the shadows, logging the results. This allows for observation of how the new version behaves in real production traffic without exposing it to end users. Netflix uses this strategy to help them identify issues or performance bottlenecks without any risk to actual users. It's often combined with another secure strategy like Canary deployments. Strong combinations such as this make it very likely to find bugs, if any, before the deployment is fully complete. The drawback of this method is the cost of implementation due to the need to run two environments that can handle production loads simultaneously. Also, in the event that bugs are found, digging into the shadow logs to identify them can be very tricky. All of the deployment strategies I've mentioned have their strengths and their weaknesses. There is no one size fits all. No single strategy is the perfect solution for every situation. The basic deployment is fast and easy, but harder to roll back to previous versions. Rolling deployment reduces the risk by updating modules gradually, but it takes longer and requires backward compatibility. Blue-green deployment eliminate downtime and allow for quick rollback, but requires maintaining two identical environments, and isn't ideal for incremental changes. Canary deployments release updates to a small group, reducing risk, but it can be slow and requires careful monitoring. A/B testing allows for testing variants of updates with small groups, but it too can be slow and requires the selection of the test audience. Shadow deployments test the new version in parallel without impacting users, providing real-world data with minimal risk, but it adds extra cost and complexity. In determining what strategy or combination of strategies work best for you, you'll need to analyze factors such as the critical nature of the update, the speed of deployment required, the level of risk you're willing to take, the resources available, and how easily you need to manage rollback or failures. So the next time you're about to deploy an update, ask yourself these questions. They should ultimately guide your decision. Ideally speaking, you always want to have a way to roll back in case something goes wrong. Let me know what strategy CrowdStrike could have used to avoid the incident. I think they should have used Canary deployments to test the updates with a small group of certain users before it became widespread. Let me know your thoughts down in the comments below. That's it for this one. For those of you who are new here, my name is Uma. I am a software engineer, career coach, and content creator. I enjoy learning and breaking down complex technical topics to make them easy for you to understand. I also coach software engineers through technical interviews and other career aspects to help them learn and increase their earning potential. If you found this video helpful, don't forget to give it a thumbs up and subscribe for more deep dives like this. If you'd like to be coached by me, click the link below or go to umacodes.com. Also check out Beyond the Build podcast hosted by me and my good friend, where we talk about all things software engineering. Thanks for watching, and I'll catch you on the next one. Until then, peace.